In this video, we will continue where we left off in the Intelligence section in MyEducator, where we describe how to use Excel Solver to solve linear programming optimization problems. As you can see here, we have already defined our linear programming problem for Mark's Donut Shop. We want to maximize profit, and we have modeled mathematically as an expression that profit as the sum of the quantity of each type of donut that we will sell times the profit that we get for each type of donut. We're subject to demand constraints. For example, we expect to sell between 150 and 250 donut holes, and demand constraints. We know how many hours it takes to make each type of donut, for example, 0.02 hours per donut hole. We've modeled the total time that it takes, the total labor used, as an expression, and we also have set this to be less than or equal to 20 because we know that we do not have more than 20 hours of labor total available. Now, in order to use Excel Solver, we need to use our spreadsheet accordingly so that it is easy to input the values that we need when solving. First, you'll notice that we have a cell for profit, a single cell. This is because when we define the objective function, Excel Solver is going to ask us to pinpoint one particular cell. So what we need to do is, similar to this expression, we need to put this expression into this cell that represents profit. As you can see here, it's already been filled out as what is called the sum product of the quantity of each type of donut made and the profit per donut. So what this function is doing is taking this number of donut holes times the profit plus the number of regular donuts times the profit plus the number of special donuts times the profit. And that sum product is the same as our objective function that we defined the expression and stays neatly in our profit cell. We have empty cells here that Excel Solver will fill in for us. We will tell it to fill in these cells to define the solution to our problem of how many of each type of donut we should make. For example, and notice that because we've already defined the profit expression, when we put in numbers here, so perhaps we want to make 10 donut holes, 20 regular donuts, and 30 special donuts, you can see that the expression for profit reflects how many were made for a total profit of $21.20. Let's get rid of that for now. We also have some information like cost to make and sale price that was used to calculate how much profit we get per donut. Additionally, we've taken the amount of labor that it takes per donut and put that in our sheet. So for example, it takes 0.02 hours to make a donut hole, and so on. We've also put our demand constraints for each type of donut in the same row. So you can see that we expect to make between 150 and 250 donut holes inclusive. In order to use the labor constraint, we also, similar to profit, need to define a specific cell that holds the expression, as you see here, for the total labor used. So in a similar fashion, we use the sum product function to multiply the quantity of each type of donut made by the amount of labor that it takes to make that donut. When we do this, similar to profit, you can see that when we add numbers of donuts that we make, the total labor used increases. So if we make 10 donut holes, 20 regular donuts, and 30 special donuts, we will need 3.3 hours of labor. We've also put the number 20 here, which will be used in our constraints, because we can't use more than that number of hours of labor. Let's clear this out and open up the Excel solver dialog. If you've already added it in, you'll go to the Data tab and click on Solver. If we take a look, we see several things. First, it asks us to set the objective. Now in your mind, this should trigger objective function. So it's not just an objective. Our profit is modeled as an expression of the profit of each type of thing we're making, or the sum product in this case. So what we can do here is click here, and then simply click the cell for profit that we've already defined, and return. Here we see it asks, do we want to maximize, minimize, or set to a specific value? Maybe we want to have a certain amount of profit. In this case, we want to maximize, so we'll keep that selected. The next box asks us by changing which variable cells. From the reading, you should know that these are the decision variables. The variables that will change, in this case, the number of donuts that will change in order to maximize profit according to the constraints. We can again click here and highlight the cells that we want to be changed by the solver program. In this case, B7 to B9. The next large box shows us subject to the constraints. Notice that I used the word subject to in the linear program. So subject to the constraints of demand and labor. Let's go ahead and start by adding the demand constraints. In order to do this, we choose Add, and then it asks us for cell references on the constraints. So for example, we want the number of donut holes that's going to be made to be less than or equal to 250. And since we already have it in a cell, we can just choose that cell. Let's add another constraint. We also want the quantity of donut holes to be made to be greater than or equal to 150, as defined in the problem. Let's continue to add the rest of the demand constraints. We want the number of regular donuts to be less than or equal to 200. We also want the number of regular donuts to be greater than or equal to 100. Finally, we want the number of special donuts to be less than or equal to 150. Oops. There we go. And the number of special donuts to be greater than or equal to 50. Now we've added our demand constraints. What we need to do now is add our labor constraints. In this case, we want the total labor used. So see, isn't that nice that we put the expression using sum product all into one cell, to be less than or equal to 20. Let's go ahead and add that. Finally, although it might not matter when we do the solving, we want to make sure that the number of donuts that we make is not a fraction. In other words, we want them to be positive integers. So what we can do is take the number made and set that equal to integer. And notice that I was able to highlight all three cells that I wanted to set to integer at the same time. Let's add that as our last constraint. To exit the dialog, I hit cancel. And now if I look, I can see I have my objective function, this cell, the cells, my decision variable cells over here that are going to change. We're going to maximize the expression of profit. And I have all of the constraints, both demand and labor, as well as the constraint that we want the number of donuts to be an integer. The last thing that we want to do before we hit solve is to choose the simplex LP, if it's not already chosen, method of solving. LP meaning linear program. The other methods can be used for different types of problems with more complex expressions, objective functions, and constraints. But for the purpose of this class, we will always use simplex LP. All right, now that we have also, let's make sure, get those options look correct. Let's go ahead and solve now that we have everything straightened out. Okay, so we see solver results. Solver found a solution. All constraints and optimality conditions are satisfied. Wonderful. So what this is telling us is that it was able to find a solution, in other words, a number of each type of donut that was between the restrictions of demand and that would allow us to use, actually in this case, the maximum amount of labor that we could. If we didn't find this, however, we might have to adjust some constraints, but we'll leave that for another time. Let's hit OK. So what is our maximum profit? In this case, we see that the maximum profit, given the constraints that we have, is $120. And in this, we would make 150 donut holes, 130 regular donuts, and 150 special donuts. From this point, you will also learn how to solve minimization problems and deal with trickier constraints, as your instructor will discuss in class.